Hello, here we're looking at notes 1103 on cross sections and rotations. There should be 3 videos linked in the instructions. I really would prefer you watching those first. Those give you good animation to understand this topic, which I can't be doing without standing in front of you. But again, if you've watched those 3 videos, this is just a quick summary of what you might have seen. A cross section is the intersection of a plane, meaning a flat surface, and a solid. Okay, so we want to think about if you have a loaf of bread, if you have an orange maybe that you're going to slice, any kind of vegetable, okay? If you're thinking, like here, I'm going to draw an orange, okay? And you're going to slice with a knife through the middle, okay? Your knife is the plane, and the orange obviously would be the solid. But here's a bunch of diagrams, starting with a pyramid. Describe each cross section. So this cross section here, this plane, it's kind of light green color, if you can see it on my screen. That plane is parallel to the base. So that's important wording for some of the questions you're going to be seeing on your homework. And that will give you a smaller version of whatever shape the base shape is. So if this is a square pyramid, that's going to be a smaller square measurement. This next plane in the middle diagram, that plane goes perpendicular to the base, meaning that this plane, this flat surface, this two-dimensional surface, and the bottom of that pyramid are making right angles to one another. So you got to imagine that standing up. But that cross section there for this pyramid is going to be a triangle. Okay. And if we go at a angle to the base, so this is slicing from the side, not from the point of the pyramid through, that creates, a trapezoid. Here's a cross section of a rectangular prism. Again, this one is going parallel to the base, creates a square, and that square, again, I draw it more rhombus or shaped because it's at an angle with its perspective. But that square and the base should be equal shapes. Here we're going perpendicular to the base. So that cross section would be a rectangle. And here, the bases, remember, to a triangular prism are here. So this is going parallel to the base. Okay. So there's a couple images. When we're looking at a cube, we can create a square. We can create a rectangle. If we kind of slice off the corner, like if you think of a brick of cheese, you can kind of go at an angle to it and slice that off. For a cone, when you go on a diagonal here, you're going to get a semicircle. As the cross section will be that two-dimensional figure. Again, parallel to the base would be a small circle. I know it looks oval shaped, but it'd be a circle. And here at an diagonal through the sides would be where you would form an oval. A cylinder going perpendicular to its base does form a rectangle. And I believe there was an image of them slicing a soda can in half, and you could kind of see that. Parallel to the base, you create your circle, and at a diagonal, one corner to the other, you can almost think of a straw in your picture, right? But that would be an oval shape. Any cross section of a sphere will be a circle. And here's the practice page. So if you guys want to pause the video, try these on your own first and then review the answers to know that you're doing them correctly. This cross section is going to create a rectangle. This cross section goes parallel to the base. And that's going to create a square. And again, you can see that these sides were each 6 and 6, so that's how I knew it was a square versus a rectangle. Draw and describe a cross-section obtained when the sword slices the 3D figure. Start where the sword rests, near or far, and follow the direction of the arrow. So if that arrow slices through the cone, it will create an oval shape. And that looks more almond than oval. Sorry about that this morning. Looking at number 4, this is going to create you a trapezoid. Number 5, if it's going straight down, that's going to be perpendicular to the base. That creates a rectangle. Now looking at 6 and 7, determine the shape of the 3D figure generated by rotating the 2D object. So looking here at this rectangle, that rectangle isn't just staying on the sheet. It does go 3 boxes over and 1, 2, 3, 4, 5, 6, 7 boxes up. But that 3 and 7 is actually going to be measurements to find the volume of the shape. So we're going to sketch this as if that rectangle is rotating around an axis of x equals -1. So if I draw in a vertical line at x equals -1, we're going to think of that rectangle with this corner here is going to rotate around that axis. Actually, every point on that side. Now, I just rotate the vertices. So if this corner goes back, think about it going back into the page and coming back out. Okay. My first little sketch there was a little funky. Okay. But that rotates around. That's going to create you a cylinder. Right. So there's our cylinder. So that 3 and 7 now actually act as our radius and our height. So if we write down the volume formula for a cylinder, goes volume equals pi r squared h. The radius of our cylinder is now going to be 3. And the height of our cylinder is now going to be 7. So if we want to find the volume of this image, 9 times 7 is going to give us 63 pi is big. So they just asked us to calculate to the nearest tenth. So I'm going to do it in terms of pi first. So 63 pi is our answer, and that to the decimal place of the tenths is going to be 197 point, it goes 92, would be 197.9. Okay. So again, the radius was 3 units because the length of that rectangle was 3. Its whole diameter would have been 6. And the height was 7 boxes tall. Now, if they asked us to rotate around a different axes, our volume would have completely changed. So I just want to explain that for a second. If they had asked us to rotate around the x, I guess the x-axis wouldn't have worked there. Rotate around that line here, y equals -3. Okay, if that's what they asked us to rotate around instead, that rectangle would have flopped down this way, and it would have rotated in a long, very long cylinder. I don't know if you guys can see that with my sketch here, but that means that 7 would have changed to become the radius, and that can, if you almost think of a tuna can going vertical like this, the can's height would have been 3. So that would have kind of changed the measurements in your formula, and you would have squared 7 and then multiplied that by 3, which would be 49 times 3 would have been 147 pies. Moving over to the second example here. Rotate around y equals 2. So y equals 2 is this horizontal line up to. And if we rotate a triangle around, okay, we're going to take the vertex here of this triangle and rotate it back and forward. We're going to create a cone. Now this vertex is on the line of reflection or rotation. So again, I usually try to reflect the image down and then I kind of connect them here. But that cone's volume equals 1/3 pi r squared h. So the height, I missed where seeing. Just start up here at 4. So 4 to -3 is the height of the cone. So that's going to be 7. That's how high it stands from the base to the top. And the radius is 2 boxes. So 2 squared. So 1/3 pi times 2 squared, 1/3 times 4 times 7 is going to be 9 1/3, which becomes 28/3 pi. And that rounded to the nearest tenth would be 29.3. Goes 3, 2, 1. So 29.3 is going to be our volume there. Okay, please try the attached questions. It says the problematic quiz, problematic classwork. Please put your answers there and also upload a picture of your handwritten work for what you can. I appreciate it. Have a great day. Thank you.